Okay, today's lesson is, you know what, let me just, okay, today's lesson is where a line and a plane meet. So line, plane. So we have a plane and there's a line. And the first question is, where does it meet? So where do they intersect? And the second question we want to know is, at what angle? Sorry. And the second question is, at what angle? And the idea is we know the angle it comes in. So the question is we want to know, at what angle like it comes into the plane. Okay, the best way to do this is through an example. So example one, find the point of intersection between line whose equation is r 1, 2, 3 plus 3, negative 1, 1 t. And once again, know how to get all those forms into the form of a line because it can be written many different ways. And the plane, usually they use pi to represent the equation of a plane, which is 3x minus 5y plus 2z equals 23. Now, obviously, you can go to GeoGebra and draw on the line and put in the plane, and you'll see that there should be a button for like the intersection. But let's see how we can do it mathematically. Well, first, write the line parametrically. This is interesting. We're reintroducing the t. So we know that this is x, y, and z. So you know what? We have our x is equal to, let's see, 1 plus 3t. Our y is equal to 2 minus t. And our z is what? 3 plus t. Well, second, this is kind of cool. Substitute your x, y, and z into the plane. So instead of having a one equation with 3 unknowns, we have one equation all in terms of t. It's kind of cool. Substitute x, y, and z into equation of plane. And what do we got? We got 3 times 1 plus 3t plus, minus 5 times 2 minus t, right? Plus 2 times 3 plus t is equal to 23. Now you have a basic linear. Now this is kind of cool. Let's think about this. Well, let me do the math. You can skip through this. 3 minus 10 plus 6 plus 9 plus 5 plus 2 equals 23. I combine the t's together. What do we have here? We have 9 minus 1. 9 minus 10 is negative 1. And we have, 14. Hold on 1 second. I wanted this to be 12. Why did I make a mistake? 1 plus 3t, 2 minus t, 2 plus 3. I got 3, 9t. I got negative 10 and a t. Oh, it's fine. You know what? I made a mistake. That's fine. We can follow through. Regardless, -1. We're going to manipulate this. I apologize. I made a little mistake, but I want to start over. So this is 14. 16t equals 23. So you know what I'm going to do? I'm going to change to 31. Sorry. Let's change to 31. Right? 31, 31. So we have, sorry, 31. So we have the nice answer of 16t equals 32. T equals 2. Sorry about that. Now, here's something really cool. We don't have our answer yet. But we know when the line intersects with the plane. So this is the when. This is the when. We still don't have the where, but we have the when. The location is dependent on time. When the location is dependent on time. I think that's kind of interesting. So we know when it's going to meet. So this rocket takes off at 12 o'clock. It reaches the ground at 2 o'clock or 2 hours later. Well, next thing, how do we find the where, the when? Well, stick the t in here. T equals 2. That means x equals 7. Y equals 0. Just a number, right? And z equals 5. And so it's either like the point or the position vector to 2, 7, 7, 0, 5. And that's how you find the intersection between a line and a plane. Nice. Let's figure out how to find the angle between the line and the plane. So I'm going to erase this now. Okay. Nice. Good. Okay. So the question is, how do I find this angle? Now you can say, Mr. Adler, it's easy to find the angle between two vectors. I just need the direction vector, and I have the direction vector of the line. The problem is you don't have a direction vector of any line on the plane because there's so many of them. Well, you do know a direction vector that is unique, that is related to the plane, and that is the normal vector. You have the normal, and that is unique, right? So we can find the angle between the normal and the line, and we'll call that beta. Okay? So in order to find the angle between the line and the plane, first find the angle between the line and the normal to the plane. Okay? Because that is consistent. Once again, there's an infinite number of lines through this plane. I don't have to find it, but what's unique is that this normal is unique. So the question is, how are we going to find the angle? Well, I want beta. I still want omega or theta. I want theta, but you know what? I'm going to have to start here. So let's find beta. So we know, first of all, I need the direction vectors. Well, let's go back to our example. You know that the direction vector of the line is, it was 3, -1, 1. And the question is, what's the direction vector of the normal? Well, we remember from the last class that the direction vector and normal are the coefficients from the equation of the plane. So the equation of the plane was 3x minus 5y plus 2z equals 30. What was 31? We changed it to 31. Well, I don't care about the 31. But therefore, the direction vector of the normal is 3 negative 5, 2. So I can find beta. So you're like, fine, Mr. Rather. The cosine of beta, right, is equal to what? Well, that's equal to the dot product. So it's 3, negative 1, 1, dotted with 3, negative 5, 2, over the magnitude of 3, negative 1, 1, dotted with the magnitude of 3, negative 5, 2. And that gives us, you have to figure this out. You can actually put this in your calculators. This would be a calculator problem. I can't imagine. Well, first of all, you know it's a calculator problem because you need to find the inverse cosine. So it's going to be a part 2. We get, let's see what the answer is. We end up getting, well, it ends up being 16 over radical 11 times radical 38, which is 16 over radical 398. Now, I want to take a step back here because I want to finish this faster because we're mathematicians. So I want to take a look. I don't want beta. I want theta. That's the angle. Beta is not the angle between the plane and this line. Well, let's do a little trigonometry. So let's take a look at this. The cosine of beta is technically the same thing as the sine of theta. And so, in general, when I ask you to find the angle between two lines and we use cosine, in this case, to get the angle between the line and the plane, you're going to do the same thing. Direction vector, dot with direction vector, divided by the product of magnitude. But now you're going to do the sine of theta. And in this case, you're going to take the inverse sine to find this angle. Final answer. What's the final answer? We get 53.3 degrees. So that's how you find the angle between a line and a plane. Find the direction vector of the line. And this is like, you have to figure out how to get the direction vector off the line, because we know the line is going to be in many different ways. And then you find the normal, which is going to be very straightforward. You take the coefficients of the equation of the plane, that's the direction vector of the normal. And then you find the angle between those two, but instead of cosine, you use sine. Good. Let's try an example, and then we're done. Try this on your own. Let's see. So, copy this down. I'm erasing. Nice. And let's do another one together. And that's basically it. Let's see. I have my next equation is, let's see, the line is x plus 2 over 5 equals y minus 3 over 2 equals z minus 5 over 3. This is an easy equation. There's going to be like just messiness in here. Like, prepare for it. And then we have the vector. We have the plane. Let's see. What did I say? 2x minus 3y plus z equals 13. So I want you to find when it intersects, where it intersects, and what angle it intersects. Pause the video. Okay, we're back. Let's see what we want to do here. So, first of all, let's find the t. So I know that x is equal to 5t minus 2. Because each of these is equal to t. I know that y is equal to 2t plus 3. And I know that z is equal to 3t plus 5. Remember, take this x, y, and z and plug it in the equation. So I have 2 times 5t minus 2 minus, if you mess this up, just follow. Okay. Let's take a second to discuss what happens when you've made a mistake. If it's a part 1 question and I switch the sign, I'm going to end up with an ugly fraction. Follow through. you will still get credits. If it's different parts, you will get credit for following through with your wrong answer, but applying it correctly. So do not stop. If you have the time to go back and figure out that, like, oh my God, I forgot I wrote this as a minus instead of a plus, you can go back. But if you don't have time, follow through. You're still going to get a bunch of points. Okay, so I found my mistake. So it's 2t plus 3. Let's see, plus 3t plus 5. That equals 13. You have to be very careful. They're trying to get you. This is not like, it's just basic stuff and you make one little mistake, it happens. Let's see, we have 10t minus 2t plus 3t minus 4 minus 3 plus 5 equals 13. Did I manipulate this correctly? Let's see what's going on here. 8 plus 3 is 11 equals, let's see, 7, 2, yeah, this is negative 8. No, I think I made another mistake. Let's see, negative 8, 3. What did I do now? I meant this to be, oh, no, I'm sorry, I forgot. Follow through. So once again, I made a mistake. Let's just actually use this as an example. So 7, negative 7, negative 2, this ends up being 15. This is a part 1 question. You know you've made a mistake. Just follow through. Take the t and plug this in. I immediately recognize my mistake. Erase. I'm sorry, because you're writing in pen, draw a line through it and start over again. So you put the cursor, I forgot the 3 over here. Sorry about that. This is a good example. Start again. 10t minus 4 minus 6t minus 9 plus 3t plus 5 equals 13. Let's see, what do we have here? 10, 4, 7t, negative 4, negative 13, positive 8, no, negative 8 equals 13, 7t equals 21, t equals 3. This is good. Once again, if you make a mistake, just draw a line through it and rewrite it. You can't erase because you're writing a pen. You make mistakes, it happens. Do not cross something out until you absolutely know how to correct it. If not, just leave it. Because the second you cross something out, they don't look at it. But if it's not crossed out, I know I'm rambling during this video. If you write 2 plus 2 equals 4 and 2 plus 2 equals 5, because they see the correct uncrossed out answer, they have to give you full marks. So do not cross anything out unless you absolutely know you have something to replace it with. Let's move on. T equals 3. So that means x is equal to 13, y is equal to 9, and z is equal to 14. Nice. Now let's find the angle between the two lines. This is very straightforward. To find the angle, first find the direction vector of the normal, which is what? It's a 2, negative 3, 1. And the direction vector of the line, that's the numbers in the denominator, 5, 2, 3. And then we find the theta, the sine of theta is equal, write this down, so it's the dot product of 2, negative 3, 1, dotted with 5, 2, 3, over the magnitude of 2, negative 3, 1, times the magnitude of 5, 2, 3. If this is a calculator problem, and you can figure out how to enter first of all, you have to write this down. But if you can figure out how to use your calculator to save all this information and just do the inverse sign, you can just write the answer down. You know what? I'm just going to write the answer down. The answer is theta equals 17.7. Therefore, the angle between this line and this plane, they meet after 3 seconds, they meet at 13, 9, 14, and they meet at an angle of 17.7 degrees. Good luck.